Good morning and good afternoon to some of you. Thank you so much for spending this time with us and joining our webinar. Today's webinar is Compliance Countdown, Preparing for MSHA's New Silica Rule. Presenting today's webinar is our very own Kristy Thornton, MSCOH. A little bit more info about Kristy. Kristy is a seasoned occupational hygiene consultant and the Director of Environmental Health Services out of our San Diego office. Bringing over a decade of expertise in industrial hygiene and environmental health and safety. Kristy specializes in conducting exposure assessments across diverse industries spanning construction, remediation, healthcare, hospitality, mining, and municipal infrastructure, and designing evidence-based health programs to manage chemical, physical, and biological hazards. She also partners with engineering and safety teams to develop best practice solutions for reducing workplace exposure. An active member of both the American and Australian Industrial Hygiene Associations, Kristy is committed to excellence in occupational health through program design, consultation, and industry engagement. Now, before I hand it on over to Kristy, just a little bit more info about our platform GoToWebinar. As you can tell, everyone is in listen-only mode, but that does not mean you can't interact or communicate with us. As you think of questions or have comments throughout the webinar, you should be able to go up to your top right corner there with the little question mark box, and you can send us that question or comment. And when we get to our Q&A session at the end of the presentation, we'll be able to go through those with you. We also, just a reminder, will be sending out after this webinar an email with the presentation as well as the slides and Kristy's info for anyone else's use. So thank you again for coming today, and I'm handing it over to Kristy.
Great, thanks, Sam. Okay, so as Sam mentioned, we're going to be talking about the MSHA Silica rule. Some of you may have joined, wondering, is this rule going to be implemented in the next week or two when the compliance date is supposed to be implemented for metal, non-metal? This is kind of a wait and see. I think it's going to follow a similar path to the coal mine, and we're going to be waiting for an actual enforcement date. But we still wanted to get this webinar out, and talk about the rule and all of the aspects that the rule entails, so that you can get all of the knowledge and start to implement things if you haven't already. So some of the things we're going to cover today, just a bit of a background on respirable crystalline silica, the health effects, looking at the standard itself, what does it entail, and then what is required of you both as a coal and a metal, non-metal mine for the implementation of this rule, if it is to go ahead in its current format, or if there are any amendments that will come through. So starting off with crystalline silica, what is it? Where is it? Quick background, it can be found in sand, soil, rock, gravel, sandstone, slate, granite, and clay. So in all of these different materials that we have in our grounds that we're mining, that we're moving around with our haul trucks. So it's definitely an exposure risk for our workers when we're dealing with these sites, whether you're a quarry or a mine. It's all something that we need to consider when we're looking at our exposure. So if we're looking at silica in mining, it can be aerated through cutting, sanding, drilling, crushing, grinding of the material, similar to what you would see in the construction industry, sawing, scraping, jackhammering, any type of excavation, which is what we're doing in our mining industry. We're excavating the soil or the sand for production reasons. So we are also hauling that material. So our potential exposure to crystalline silica is always something that we need to consider, and it's something that we have been considering for years. It's just currently evolving as the exposure standards change under this new MSHA rule. So for those of you that have never seen a comparison table before, I find this graphic really useful to just understand the size of the particle that we're talking about. respirable crystalline silica is right down there, around the 2.5 microns. It's smaller than a droplet. It's smaller than a larger dust, smaller than a beach sand, salt. It's very small, and it can be easily then enter into the lungs and into your thoracic pathway and cause you some ill health effects. Again, the types of dust that we're talking about when we're talking about the crystalline silica is that respirable fraction. So it's not the inhalable dust, the one that gets stuck in your nose and throat and makes you kind of cough and feel a bit gross. The thoracic pathway is some of that stuff that reaches the upper respiratory tract. But the crystalline silica is in the respirable form. So it goes all the way down into the bottom. It reaches the finest parts of your lungs, into your alveoli. And it can include or cause some severe adverse health effects. It can result in silicosis, either acute silicosis, which comes on fairly quickly, within some of the research now into the benchtop manufacturing, the cutting of the granite benchtops and the engineered stone is causing accelerated and acute silicosis after 2-3 years, rather than the usual exposure that we've seen in other industries where it's more of a long-term 10-20 year type of exposure. And it can also lead to massive, progressive massive fibrosis. So it can cause us some fairly significant issues. In addition to that, some people aren't quite as aware, but it can also lead to different rheumatoid arthritis and some other symptoms that maybe aren't as easily associated with your lungs, as well as lung cancer and kidney cancer. Some people aren't aware that exposure to silica can also lead to kidney cancer. All of these that I've listed are, as you would expect, they're generally irreversible, they're chronic, they have the potential to be fatal, and exposure has a lot of research. It's been associated with coal mine dust and dust associated with construction sites and some of those materials I mentioned earlier. So this is just some x-rays of a healthy set of lungs and then a lung that has some of that advanced silicosis that I was mentioning. It really causes a lot of scarring and damage to the lungs. It's deep within the lungs, and it's almost like breathing through a straw. If you were to breathe through a straw and do 50 jumping jacks or star jumps, I'm not sure what you call them in the US. I'm Australian, so I call them a jumping jack. And try to breathe through that straw. It's really hard. It's really laborsome. It's difficult on your lungs. That's basically what it feels like to start to have this lung restriction. And then it becomes hard to just do your day-to-day activities. And it can be really just affect you in both your personal and business life. It can be really hard to deal with, and there is no cure. So we want to really prevent people from getting to this stage and developing any of these long-term illnesses. It can happen even after silica exposure has ended. So it's not as simple as a worker finished working for you after 10 years and they left. They can still then develop silicosis from exposure that they had whilst working at your facility. So we want to make sure we're protecting our workers at all times. So the MSHA silica rule, it's what we're here kind of mainly to talk about today. What is it? Where did it come from? What does it mean? The final rule took effect in June of 2024. So it has been a final rule for almost 2 years now, but there was compliance dates. The MSHA set some delayed compliance dates. There was a significant change for both coal and more so for metal, non-metal mines. So they gave a good period of time for people to start to comply with this rule. The compliance date for coal mine was last April. It was April 14, 2025. And then the compliance date for metal, non-metal is coming up on April 8th, 2026. But again, like I mentioned, there's some legal proceedings that have meant that the rule is not being enforced for coal, and it's not expected to be enforced for metal non-metal initially, whilst these legal proceedings are happening in the background. So the rule itself, if you've printed it out and had a look at it over the last year and a half while it's been out there, it is 691 pages long. It's really hard to read in some instances. It's very long. It's a little tiresome. It was published to really set, in theory, some uniform permissible exposure limits, and also an action level for crystalline silica for all mines, whether it was coal or metal non-metal, to kind of align the industry with some numbers that MSHA thought were achievable, and that the new PEL, so the new permissible exposure limit for respirable crystalline silica, is set at 50 micrograms for a full shift exposure, and MSHA calculates a full shift based on an 8-hour time-weighted average calculation, and then the action level is half of that number, again at 25 micrograms meters cubed, and that's also based on a full shift 8-hour time-weighted average exposure. And one of the major provisions really in this rule set out that mine operators are required to conduct exposure monitoring for silica, and that they also should immediately report any overexposures to MSHA and take action to lower that concentration as well. The aim really around this whole rule is to lower the exposure and to put a focus on controls, with a really heavy emphasis on engineering controls to try and restrict exposure and control exposure to our workforce. The current, the PEL prior to this was 100 micrograms, so it's a significant shift. It's a really big reduction for this industry, and it's one that a lot of people thought may be difficult to kind of undertake, which is why MSHA initially put the grace period for people to start to do some monitoring and to lower their exposures before MSHA started to come out and enforce it. As you know, or you may have heard, there are currently some legal challenges. It's in the Eighth Circuit Court of Appeals at the moment, backwards and forwards with what the outcome of that is going to be. At the last update I read, MSHA was considering putting some new provisions and amending the rule slightly. So I think it's still a watch this space type of scenario as to what will be finalized in the rule. But some of the details in the rule, I anticipate, and a lot of others anticipate, will stay. So we still want to cover them and make sure that everybody understands what they are and what some of those requirements may be. Again, in that rule, if you've read it, the numbering system is quite bizarre. It goes from 1, 2, all the way to 10, 11, 12. 3 to 9 just don't exist. I'm not sure who numbered the rule, but if you've looked at it and wondered where those sections are, they are not part of the rule. So again, the final rule, or this rule, establishes a uniform permissible exposure level for respirable crystalline silica. So it's the same number for coal as it is for metal non-metal, and that applies to quarries or anybody under the MSHA regulations. They did lower that exposure standard, so it's now a permissible exposure level of 50, again over that 8-hour time-weighted average. We all understand that in the mining industry or in these heavy industries, we generally don't work an 8-hour shift. We have employees working 10 hours or 12 hours. So we need to be able to shift adjust our exposures and calculate them based on, we want to sample for the full shift, but then compare against this 8-hour time-weighted average that MSHA has released. And then the action level, again, is half of that point, so at 25 micrograms. It applies to all 3 forms of the silica polymorphs, if you're aware of them. So it applies to both quartz, cristabalite, and trinamite. We need to look at all of them when we're looking at our laboratory results to make sure we're considering respirable crystalline silica in its entirety. And the former exposure limit, the 100 micrograms that existed, came from an older document from 1973 from the American Conference of Government Industrial Hygienists, the ACGIH. So it was an older document, an older number that had been in place for many, many years. So in a lot of people's opinion, the change needed to happen, but whether this is something that can be implemented in the mining industry and how effective the rule itself and some of the other onerous components of the rule can be implemented will be something that we need to wait and see a little bit. So a little comparison for the Silica rule. The new PEL of 50 is consistent now with OSHA's 2016 final rule on respirable crystalline silica, and that number applies to construction, maritime, and general industry. So MSHA has now aligned itself closer to what OSHA and NIOSH had implemented a few years ago. So a lot of people think that's the best for the industry as well, to make sure that we're protecting our workforce in a similar way that other industries are doing as well. It also aligns itself with NIOSH and what the NIOSH research is saying, and their criteria for the recommended standard for its crystalline silica exposure. Construction industry, implemented a lot of different guidelines and guidance materials. If you haven't had access to some of the OSHA construction material, it's quite easily accessible on the internet, and it has some good ideas for control measures and things that they've implemented in that industry. There is a little bit of an overlap and some useful tools that you may be able to pull from that to implement on your own sites as well for mining related exposures. So when we're looking at the exposure monitoring, which is a really big part of this Silica rule, we're talking about an action level of 25 and a permissible exposure level of 50. Both of those numbers have different responses tied to them. If you are equal to or above the action level in your exposure monitoring, then you are required to perform periodic monitoring. If you do exposure monitoring and your sample is above the PEL, so above that 50 micrograms, you are then required to perform both corrective actions and implement a respirator by the next work shift. So if you sample on a Monday, you get results back by Tuesday, workers in that area or in that work group are required to wear a respirator whilst you're implementing your corrective action plan. So because of that, because they've written that in the proposal, in the rule, it may require that you have to have a respiratory protection plan already in place. If you anticipate that exposures may occur on your site, you then need a respiratory protection plan for those workers that may need to wear a respirator, even though it can only be used as a temporary measure. Another requirement of the rule is that you notify MSHA immediately when you have any sample result that exceeds the PEL. Again, this is another one that has been a little contentious. What does that mean? Are you then self-reporting an overexposure and allowing MSHA to enter your site and start to audit you, or just what's the background or the reasoning as to this immediate reporting for exposure? Also, if you are below the action level, you need to resample once within 3 months, and then again, if you get a second result that's below the action level, you are able to discontinue sampling for that work group based on the periodic evaluation. So you do need to sample at minimum of twice based on this new rule to make sure that your exposure is below the action level. And that applies to all work groups in all areas. It's not as simple as you sampled one worker on one day and another worker on another day and they were both below. We need to look at where all the potential exposure is over your site. And then on top of all of the additional exposure monitoring, there is also a requirement for periodic evaluations, and they need to occur at least every 6 months or whenever there is a change. So that change might be a change in your production process, some new equipment that you've brought onto the site, even a change in the geological conditions. You're decided to mine in a different area, or you've come across a different product. All of those need to be considered when we're looking at the periodic evaluations. Your periodic evaluation can be as simple as we reviewed it, we did a mini audit on our program, our production is the same, our workforce is the same, the way we're doing things is the same, the rock that we're drilling into and mining is the same. So we can write a written evaluation that says nothing has changed, our exposure monitoring, our exposure assumptions remains the same. But if any of those things change, you need to perform actual sampling. So it's a mixture of qualitative and quantitative exposure and risk assessments throughout the year, basically, as you're going through your exposure monitoring. And there are site personnel, site safety teams that can probably help with this. You can also use occupational hygiene firms to come in and help with some of the exposure monitoring. There are lots of different ways, and people that are trying to stay on top of this MSHA rule and provide as much help as we can. So please reach out, to anybody that you need some help with for this exposure monitoring component and some of the complexities with it. Sampling records is a really important one. I think this is probably one of my key takeaways from all of this is when you're doing your sampling, take really well-versed notes. That's what's going to help you when MSHA, when they start to enforce this rule and they're coming out just for their regular checks, they're going to want to see documentation and sampling records. So what date did you sample? Who did you sample? Not only the concentrations of crystalline silica, they'll want to see what the concentrations were, but the more information you can gather on what that person or what that representative person did, the better it's going to be to set your site up for what we usually refer to as a similar exposure group, a SEG. So if you are a large site and you have even 50 or 100 workers, the last thing you want to do is sample every single one of those workers each time. That's really cumbersome. It's a lot of money. You want to be able to break them up where possible into these similarly exposed groups. So you might have loader operators, excavator operators, mechanics, electricians, just groups of workers that are similarly exposed. But we also then need to prove that we've thought about it and they really are similarly exposed. So how are they similarly exposed? Have you looked at the areas that they work in, the tasks that they perform? What kind of written data and information do you have that shows that you've done some critical thinking and that these workers are all in the same group? Do they work a similar shift? Do they work in a similar location? Do they deal with similar equipment? That's all going to be information that reinforces your sampling plan when MSHA comes out and looks at it. And then additionally, when you've performed your sampling, you need to post a record on a mine bulletin board or on an electronic platform if you have one, and it needs to be accessible to your employees for 31 days upon the receipt of exposure monitoring. So we can't just collect the information and file it in our offices. It does need to be made available for the workforce to view as well. And that's another thing that MSHA will just be checking when they're out there. Do you have a means of sharing that information with your workforce? So the exposure monitoring, you've probably all seen a sampling pump before, so I'm not going to go too much into this, but it does follow Part 60 of the rule. It outlines the requirements for exposure monitoring. It outlines the need for the sampler to be within the person's breathing zone or on their lapel, basically on their collar. The photo in there is probably even a little too low for the location of where you want the sampling head to be, but under the Part 40, MSHA requires that mine operators use respirable particle size selective samplers that conform to the ISO standards. So you just want to make sure that when you're doing the sampling, you're using samplers that comply and that can be audited as well. There are different versions that you can use. MSHA hasn't been too restrictive on the type of size selective sampler that you need to use. So that's up to really you and what you find the easiest and the most accessible for you. You just need to make sure that they're complying with the standard. You use any type of sampling device. It just needs to be designed really to meet the characteristics of the ISO standard. And here's an example of a few different options that you might see out there. Again, you're able to use any type. It just needs to be complying with that ISO standard, like I mentioned. So just again, on that similar exposed group, that's where we want to be leading our sampling to in the end, is looking at a group of employees. They need to have the same general exposure profile because of the similarity and frequency of the tasks that they're performing. They need to have similarity of materials and processes with which they work, and a similarity in the way they perform tasks. That one's a little more difficult because each individual might do something slightly different, but we just want to make sure that we have as much written evidence that we have categorized people in the correct groups for their exposure profile. Shift length, again, under Part 60, the permissible exposure level and the action level apply to a miner's full shift exposure. It is calculated as that 8-hour time-weighted average, but the sample should occur for the full duration of the miner's shift. So if they're working a 10-hour shift, you should collect the sample for 10 hours, but the results are compared against the 8-hour TWA. Again, you might have trained hygienists or safety personnel on your site that can assist with this further, but it adds a little bit of complexity to some of the sampling that we just need to think about. It's not as simple as kind of putting a pump on and running it for a few hours and then looking at the result we get. We need to consider the time-weighted average exposure. Laboratories are another thing that the MSHA rule calls out as well. You just are required to submit your samples to a laboratory that's accredited against the ISO standard to analyze samples for respirable crystalline silica. The method that they analyze against isn't prescriptive. You can use there's methods by MSHA, by OSHA, by NIOSH. You just need to make sure that they're an accredited laboratory. The American Industrial Hygiene Association has quite an easy to use website where you can look for accredited laboratories as well if you need that resource. The methods that they're using, you want to make sure that they're distinguishing between the 3 silica polymorphs if possible, so that your lab report might come back and it might have exposure to silica as a whole and then the 3 polymorphs separately. And we want to look at all of that when we're considering our exposure profile and our risk. So you've spent all this money and you've spent all your time doing this exposure monitoring. You get the results back. What does it mean? What do you do? This is, again, one of the areas of a bit of contention with the MSHA rule. You're required to immediately report overexposure to your MSHA district manager, make approved respirators available to affected miners before the start of the next work shift. And an approved respirator cannot be an N95. It does need to be a 100 series, so a P100 potentially or above. So you can't just have a storage of N95s that you're using. And you also need to consider the corrective actions. They need to be taken as soon as possible to lower exposure to below the permissible exposure level. And like I mentioned earlier, your employees need to stay wearing a respirator until you have sampling results that show that exposure is below the PEL. And I know that there's an issue, or a lot of the labs potentially get backed up sometimes. And if we're sending a result and it's on a normal turnaround, that might be a 5-day turnaround, and then you have employees in a respirator for 5 or 6 days. You need to consider, is it more cost effective to pay the faster turnaround, a 24 or a 48-hour turnaround, additional fee on your labs to get a result back faster, to remove your workforce from wearing a respirator? All things to consider if you are starting to get exposure results that are above the permissible exposure level. And again, you're conducting your sampling pursuant to the regulations, to the 60.12 Part B talks about sampling and the corrective action log. You need to log what you did, what your response was. Again, that's going to be one of the components that MSHA, if this rule is enforced, that they start to look at when they come out. What are your corrective actions logs? Where are they? What do they say? Did you do and respond in a timely manner? And what corrective actions did you implement? The focus really is on engineering controls as much as possible. That is a big ask for a lot of companies, but it's not as simple as, I rotated my workers. You can't use rotation as a control measure at all under this rule. And that is a little outside of what OSHA recommends and things like that. So that's one of the points that is in the legal proceedings as well, is why can't we use rotation as a means of control for crystalline silica if it is an issue in our workforce? So the hierarchy of controls, you've all seen it and heard it many times. Elimination is the first means. Eliminating crystalline silica in a mining format is basically impossible because we're working with the ground and the material in the ground and the product. So elimination is one of the most difficult to do in this industry. Substitution, again, we are mining or drilling or quarrying for a certain product. We are using that product for a reason, so substituting it may be difficult. So engineering controls becomes the focus of this act and where MSHA wants companies to promote and prioritize the most. Administrative controls and PPE are those bottom two, as they always are in the hierarchy. So engineering controls that may work for you if you aren't considering them already, enclosed cabins, re-looking at your machines and your production material that you have on site. Do you have good door seals? Are your cabins filtrating properly? Just what is the general upkeep of your equipment? Do you have water trucks that are wetting down your haul roads? When you're digging and moving things, is there any way to potentially wet or mist down the material? Wetting a material obviously adds money and time to the production process. It can slow down conveyor belts and it can really have a big issue. But is there a way to just mist or gently reduce the airborne dust in the way that we're doing things? MSHA does only allow you to use administrative controls to supplement when necessary these engineering controls. So they can't be used as the only means of control. You need to have some form of engineering control that you have tried. And again, the rule forbids the use of rotation of miners. Some more examples here. Covering your conveyor belts can potentially reduce the exposure to nearby workers. Water trucks, misting sprays. When we're using water, we definitely need to consider the particle size of the water. Really heavy water isn't going to suppress light respiratory silica type particles. They're going to float higher up into the air. So significantly wetting something probably won't also work. You need to look at, maybe work with your engineering team on what type of mist, what type of particle size you need for your water to capture the particle size of the dust that you're concerned with. Add spray nozzles to processes if you can. And again, vacuum, you can use HEPA vacuums to vacuum off transpo points. Maybe that's a potential for you. Can you contain an area like they've done in this picture here over the conveyor belt? It can sometimes be an inexpensive mechanical solution to some of our dust producing areas. Some more examples, for your more, if you have any jackhammers or any kind of smaller tasks that teams are doing, you can get water suppression on the tools if they're using hand tools at all. Maybe you have a production area where they're doing some other processing of your material. Potentially water suppression on tools might work there. Again, enclosed cabins, enclosed mobile plant cabins, fixed plant control rooms. Can you operate from a distance? Do you have to be physically present on the mine floor? HEPA vacuuming attached to drills and things like that is all potential that we can consider when we're talking about maybe our maintenance team or our electricians that are out and about and doing some smaller tasks. Maybe we can get them some equipment that's fitted with dust extraction or water suppression to try and reduce their exposure. All the way down to those admin controls, we do still need to look at them. They can't be relied on as our only solution, but signage, HEPA vacuuming, prohibiting that dry brush sweeping, not making airborne any dust that we need to. So not kind of using compressed air to clean off our clothes. There are a lot of different dust booths and different booths that you can use to extract dust off people's clothing at the end of a shift, so they're not having to spray themselves with the compressed air and kind of aerate the dust around them. Just different little things that can all contribute to the exposure at the end of the day. Remembering that the exposure is based on a full shift, so somebody might have potentially a larger exposure for an hour or two, and then if we can lower their exposure for the remaining 6 hours to almost nothing, it may average out to be below that new PEL. Respiratory protection, in a broader change, the final rule incorporates the ASTM respirator standard for airborne contaminants. This standard applies to the selection, fit, use, and maintenance of approved respirators. Again, you can look it up online and have a read through it. There's a lot of links towards the program. It doesn't allow, shows you how to correctly select and fit masks. It's a really user-friendly document. But the MSHA rule will not allow you to use N95. So that's probably the one thing to remember with this. You need to make sure that you've got NIOSH approved respirators available on your site if you have the potential for exposure. And then if you have the potential for exposure, you unfortunately need to have a respiratory protection program. Again, respirators aren't a primary compliance method. Engineering controls need to be implemented, and you can use a respirator while those are being implemented. But like I mentioned, you do need a respiratory protection program if you have exposure. It needs to be specific to the mine's hazards and conditions. That's one of the main things that sets the program apart from some of the things that OSHA and NIOSH have been using. So your plan needs to be quite specific. It needs to look at your specific hazards. So if you're a larger company that has multiple sites, you may need a separate respiratory protection program for each site based on the hazards that are there. It may not just be able to be one corporate program that applies to all of your sites. It does need to consider some of the specific workplace hazards. And it looks at, I think it talks about the geological conditions, the process, all of those type of things. So that may not be the same from site to site for you. One of the other changes in the program or in the rule is the need for medical surveillance. For new miners, if you are employing new staff, you need to offer them an initial examination within 60 days of their employment and a follow-up examination within 3 years, and then every 5 years thereafter is voluntary. But those first two are a requirement. The medical examination will look at a medical and work history, potentially a physical exam, may involve a chest x-ray or a pulmonary function test. The issue with a lot of this is that the chest x-rays have a requirement to be read by a B reader, and the availability of B readers within the world, and in particular within the US when we're talking about this standard, is very minimal. There aren't many B readers out there. So how to meet this requirement is something that, again, is part of the legal proceedings. You know, how, if you're asking us to send out chest x-rays to a B reader and there aren't any available, how are we supposed to comply with this? Record keeping, the rule also specifies how long you need to keep your records for. It differs a little bit from the OSHA rules. OSHA normally requires 30 years, MSHA's just saying 5, so 5 years for your evaluation records, your sampling records, and your corrective action records. The duration of the miner's employment plus 6 months for the written determination records and for the written medical opinion records. So you do need to store your records and have them available based on this rule as well. Oops, sorry. So kind of just summarize all of those things, that the rule in theory went into effect on June 17, 2024. Coal mines were supposed to be enforceable as of last year. That didn't occur and hasn't occurred as yet due to the legal proceedings. Metal non-metal is due in the next 2 weeks, and again, nothing has kind of come to fruition yet as to whether that will be enforced or not. It's highly unlikely, but there is a lot of information in the rule that I think we can start to work on if we haven't already, and start to consider so that we are ready for when the new rule or the new implementations come into effect. So just a quick recap, the PEL according to the rule is 50 micrograms with an action level of 25. It applies to miners exposed or reasonably expected to be exposed. So basically that's everybody on your site that you consider to be exposed to a dust needs to be considered in this program, and the exposure is determined based on that 8-hour full shift sampling. The hierarchy of controls under the MSHA rule, again, focus very strongly on engineering controls. Admin controls cannot be used for compliance. They can be used as a substitute with your engineering controls. Respirators are temporary and they're only to be used during corrective actions, and an N95 cannot be used. And operators must implement feasible control, dust control methods. So if you haven't started to think about your dust control methods already, it's a really important one just to think about what you're doing, what you can be doing. Reach out to other industries, other mines, other people doing something similar to you. Ask them what they're doing, what they've seen, what's working, what's not working. Sharing information at this time is the best way for us to figure out the controls that are working. And then a bit of summary on if and when MSHA inspectors start to come out and enforce this. Some of the focus areas that I think they may be looking at is definitely your exposure monitoring program. Do you have it has it been implemented? How are you implementing it? How well are you documenting it? Again, if you have exposures, how well are you documenting your corrective actions? What have you done? What are you doing? What do you anticipate on doing? Do you need a respiratory protection program? Do you have one if you have needed it? Do you have the medical surveillance available? Have you started to do it? And are you posting and retaining your sampling records? So they're really the main things that I think MSHA, if and once this is really implemented and on board, that they will start to look at. The more we can document what we've done in the process, the better it's going to be when they start to show up. I don't think they're going to come out and start to write everybody up for not being perfect. If you've shown that you're on a path and you're trying and you're implementing different things, then that's only going to help when they come out and start to look at your exposures. Everybody's probably asking, will this stay in its current form or will it change? Again, that's up for discussion in the courts at the moment, but I think the new PEL will stay. I think it will be very difficult, if not impossible, based on some of the requirements, that they won't be able to change that new PEL. It will stay at the 50 micrograms. So that's a number that I think we should start, if we haven't already, start sampling and start monitoring your workforce based on that number, and start working towards getting your exposure below that number if you are above. And like I said, there are a lot of people working on this in other mines, larger mines, smaller mines, industrial hygiene firms, safety firms that are working on some control measures. So please reach out, share your resources with each other. And I think that's the best way forward for us to figure out how to navigate this rule when it is implemented, and the focus on the engineering controls. That was the end of the slides, and I just wanted to give time for any questions.
Sweet. Thank you so much, Kristy. And before we do get to those questions, because I did receive a couple comments throughout, just a reminder, tomorrow or Thursday, we will be sending out an email with the recording link to this presentation, as well as a copy of the slide deck. So you will receive that. So don't worry about that. And then going to the questions, we do have a few. Someone asked, so we do contract work at mine sites, 1 month to 3 months on site. Do we have to test the employees while working on the site?
That is another one of the ones that they're a little unsure of at the moment, but I would suggest that you do, yes. I mean, obviously you need to, it's a harder one, because if you're moving from mine to mine, you're also changing your the mining geography that you're, the rock that you're dealing with, the material that you're dealing with. But in theory, you should be testing your workforce, yes.
Okay, awesome, thank you. Next one is, if I have a known exposure during my testing that exceeded the action level, are N95s okay for personnel entering that area for short periods of time for audits, brief communication, coaching, instructions, etc.?
Based on the MSHA rule, an N95 shouldn't be used at all. I mean, their focus is above the PEL, so not so much above that action level. If you wanted to have voluntary use of an N95 on your site, that might be a site-based decision, but I wouldn't implement it as a requirement, because then that involves the respiratory protection plan and people need to be fit tested and trained. If it's solely a voluntary thing, then you might be able to allow that in that instance, but I would take caution to having N95s on the site, just in case they were used in a situation where they weren't allowed to be based on the rule.
Great, thank you for that. So next one, for exposure monitoring, would using FTIR for analysis be enough if an XRD lab is not available?
Yes, yeah. So again, it's probably a question that's coming up now because we're all required to monitor more and more. XRD is usually the preference and the preferred route, but if you have a really large delay or you're not having any luck with analysis through that method, you are able to use, as long as it's giving you the crystalline silica polymorphs and giving you the result, then that is allowed, yes.
Okay, great. Okay, so next one here, hopefully I don't butcher this too much. What are your thoughts on the Torlex, TROLX, AIR-IX real-time silica monitor being used in conjunction with the current accepted sampling methods with the sampling pump and cassette, or PPI? Is this something you see being approved by OSHA and or MSHA for compliance use in the future for silica monitoring?
Yep, I'm a big fan of using some type of real-time monitoring as a method of spot checking. I wouldn't use it as a compliance tool, but it's definitely a good indicator tool in conjunction with your exposure monitoring that will give you the lab result. You could use those type of monitors or different versions of that monitor to look at when exposure might peak. There's a lot of, I haven't seen any in the US, but I'm still connected to a lot of Australian colleagues, and they're doing almost a GoPro type thing on a hard hat, and they're watching for exposure as well. So they're doing visual representation of the shift in comparison to what is coming up on the real-time particulate monitor, as well as the personal exposure sample. So they're getting a really good understanding of where exposure is coming from, and that's helping them for controls. So I think it's a great tool for trying to target where your controls should focus. If you have overexposure for a certain work group, and you can use a real-time monitor to say, wow, it really peaks when that one activity happens or when that one piece of equipment operates, then that's your focus for your controls.
Great, awesome. And so just due to time, we'll wrap up with these last two, Kristy. If continuous air monitoring indicates exposures above the PEL on a constant basis and all acceptable engineering controls have been used or applicable, what will MSHA require on an ongoing basis?
Yeah, that's a difficult one, because the way the rule is written at the moment is that in that scenario, you just get stuck in a never-ending cycle of sampling and again and again and again with no outcome that says this is the best we can do. So that is one of those gray areas, as we've ticked off every box we can think of for controls. We're still above the PEL, but based on the rule at the moment, it says we need to keep sampling. So that's one of the ones that they'll need to clarify before this rule, I think, can really be enforced.
Okay, great. And then last one. So kind of combining two of them, but okay, so do you recommend, or have you seen companies making any changes yet to prepare for the new Silica rule? And if so, what's been one of the easier steps or easiest step, first step? And then kind of going off as well, do you think, or will there, like, what do you think is going to be one of the harder challenges of kind of getting that compliance started?
Yep. So I think I have seen people, a few different companies have been working towards this ever since the rule was released in 2024. There are some companies that sort of jumped on it straight away and started to work towards the goal of being below the PEL, and they've been able to implement some minor controls that have been really effective. Again, looking at their fleet of vehicles and getting rid of the older ones that have really bad door seals. It can be maybe cost prohibitive to buy new equipment. Can you reseal the doors? I worked with a company that did that. They focused on the interior of all the plant. They resealed, they did windows, they made sure that everything was kind of working immaculately, and they rewrote a cleaning program for the equipment. They also, as simple as implemented just a little boot brush type scenario before the employee enters and exits the mobile equipment, so they're not bringing dust in with them. So some smaller controls like that have really worked towards reducing exposure to plant operators. And then outside of that, in the production, being able to just enclose the dustiest part of a conveyor belt, maybe one of the transfer points, has had a significant reduction in other instances. So not having to cover the full length of the conveyor, which might be costly and time consuming, but just covering the transfer points has really reduced some of the exposure.
Great, awesome. Thank you so much, Kristy. This is all the questions we have. So we hope you all have a great rest of your day. Thank you for taking the time to be with us today. And like I said, we'll send out those emails, and we'll see you soon.
Thank you.